All right, time to learn about rotational symmetry. So rotational symmetry happens if a figure can be turned 180 degrees or less and look exactly the same as the original shape. So that's going to be rotational symmetry. So basically, can you turn this shape less than flip it upside down and it look the same? So let's look at some examples. And I've got this little turn thing to help us out. So basically, this would be 1 turn, 2 turns, 3, and this would be 180 degrees. So can this shape look the exact same at 180 degrees? Okay, and I've got a lovely star right there. So I can turn that shape less than 180 and it still look the same. Okay, on number 2, let's look at number 2. So still doesn't look the same, still doesn't look the same. Okay, so this trapezoid will never have a small base on top if I turn it any way besides 180. Obviously, if I go all the way around, it'll be 360, but it has to be less than that, so no. Okay, and then we've got a triangle over here. So notice if I turn the triangle right there, I have another triangle as well. So that can have rotational symmetry because it didn't turn all the way around. So that answer would be yes. Okay, so why don't you try 4, 5, 6, and 7 on your own? Tell me if it's got rotational symmetry or not, and if you need some help, you can try turning your paper upside down. No, yes, no. So this right triangle is tricky because you can't turn that and it still be a right triangle until you go all the way around. S is pretty cool. So if you turn S 180 degrees, you still have an S that you can read. B does not work. Can't read that B. But again, SOS works. So you can turn SOS 180 degrees and it will still say SOS. Okay. So that is rotational symmetry. So go ahead and try these. Which of the following have rotational symmetry, and give me an explanation. A and B have rotational symmetry because if you turn them less than 180 degrees, they'll still look the exact same. Now if you don't believe me, I've put the shape behind it so you can tell. So I can turn this shape a certain degree, less than 180, and it looks the exact same. Okay, it's got lots of rotations right there. B is a little tricky because it doesn't look the same, but let me flip it upside down 180, and guess what? It's the exact same. Okay, now C does not work, so I didn't put a cool little thing behind it. But A and B do have rotational symmetry. Alright, so rotating an image onto itself. I've got Goofy, and I want to put him onto itself without just translating it. I want to rotate him. Now Goofy's not cool. He only has 360 degrees. Okay, but the rule for finding the degree of rotating it onto itself, the formula is 360 divided by n, where n means your number of sides. So 360 comes from turning it around in a circle and dividing it by the number of sides. So I have a square right here, and I need to figure out what degree that was to turn that shape onto itself. So to find a square, you would do 360 divided by the number of sides, which is 4, which would give you 90 degrees. So if I turned that shape on its side from left to right, I rotated it 90 degrees. Okay, but let's look at the paper you have in front of you. So figure out the rotations that map the figure onto themselves. So use that formula and tell me how many degrees would be the smallest rotation. The triangle, if you were to rotate this shape like that, you would have rotated it 60 degrees and it looked the exact same. For this pentagon, if you rotate it 72 degrees, it will look the exact same. And then with this octagon over here, if you, oh, that's trippy. If you rotate it 45 degrees, it will look the exact same, okay? So again, 360 divided by number of sides to find the smallest rotation. If you are going 2 rotations, what you would have to do, for example, would be 72 plus 72 to get 144. So you can do multiple turns. You're just going to have to add them together. So let's look at some examples. So the diagonals of a regular hexagon shown form 6 equilateral triangles. Use the diagram to complete the statement. So a clockwise rotation of 60 degrees about P maps R onto blank. Okay, so first off, about P means the center. So if I want to turn things around this, they're going to tell you what the center is. So first off, I need to figure out what one turn is. And if I'm dealing with a hexagon, I know that has 6 sides. So 360 divided by 6. So I know that one turn is 60 degrees. So if my question wants me to go 60 degrees, I got to go move it once. Okay, so I'm going to start at R. And I want to go about the center, and I want to go clockwise. So I'm going to go this way. And I want to go one turn, so then that means R would be at S. Okay? I want to go on number 7, I want to go counterclockwise. 60 degrees, so one turn. About what would say R goes to Q? Okay, so R going to Q, one turn counterclockwise. That would have to mean that the center was P, so about P. Okay, so it went along that outside of the hexagon. All right, going clockwise, rotation 120, so that's 2 turns. About Q. So here is my new center. And this is where I might throw you guys off. So if this is my new center, these 3 pieces are touching it. So I basically can ignore all of this. Okay? So if Q is my new center, where is R going to go? If it is 2 turns clockwise. So R would go boom, boom, and it would become W. So if they get tricky with you and they change the center about what it's about, you can kind of ignore all the pieces that aren't touching the center, okay? So then R would kind of swing around this Q thing, okay? So that's where they'll get you. We'll do some more examples with that, don't worry. And then last one, you're going counterclockwise 180 degrees. So that's going to be 3 turns. Okay, if you can't figure that out, do 180 by the smallest degree, which would give you 3. About P, so we're going to be at the center, and we're going to start at V, and I want to go counterclockwise 3 turns. So I would go 1, 2, 3. So R would now be at V, okay? That makes sense because 180 just flipped it across, it's right over there. All right, so let me know if you have any questions on those. Otherwise, we're going to get some more practice. All right, so why don't you guys try this one on your own? So name the image of E for a 72-degree rotation counterclockwise about X. So press pause and tell me where E would go. First off, you had to do 360 divided by the number of sides, which was 5 for a pentagon, and get 72. So if it wanted you to go 72, that was 1 turn. And then since we were going clockwise, kind of think about this way in your head. And so E would go to P. Okay? All right. I put in this little one here for you if you need some more help where X is not the center. But I want you to name the image of P for a 260-degree rotation clockwise about X. And then if you want some more practice where X is not the center, I want you to name the image of E for a 144-degree rotation counterclockwise about N for the center. So try those 2 on your own and press pause and we'll go over the answer. gotten T for both of them. So you had to figure out how much 216 turns would be, and it'd be 3 turns going clockwise. So boom, boom, boom. And then let's talk about this one down here. So now we're going to have N for your center. So basically every piece that spoke touching N. So I can ignore all of this. Okay. So I am starting at E. And I'm going 2 turns counterclockwise. So I'm going to start at E, and I'm going to go 1, 2. Okay, and that would rotate it onto T over there. Okay. All right, one more. All right, so I added this one down here to get some more practice where M is not the origin. So try these two. We're going to name the image of BM. So we're going to do a whole line segment. 240 degrees counterclockwise about M. And then try this one. Name the image of A for 120 degrees clockwise rotation about F for the center. So try those two and then press pause and we'll go over them. The first one, I had a new shape, so I had to figure out the smallest degree of rotation by doing 360 over 6, and I got 60 degrees. So if I'm going 240 degrees, that means I'm going 4 turns. So if I start off at BM and I go counterclockwise this direction, 1 turn, 2 turn, 3 turn, 4 turn. It should be at DM. Okay. Over here, I need to name the image of A, 120 degrees, which would be 2 turns. Clockwise about F. So if this is my new center, I can move along this little rotation over here. So you had to ignore all of that out here. And so starting at A, 1 turn, 2 turn would put it back at E. So hopefully that makes more sense when the center is not at the origin. If not, I've definitely got some practice for you. So thank you for watching rotational symmetry and rotating an image onto itself. Now you can practice.